Alright, so welcome to the second part of the video, and in this video I'm just going to continue from the step that we stopped in the video number 1, which you can find the link down in the description below. And over here I'm just going to show you how to read shapefile data in Geopandas. So first of all, I showed you in the beginning of the previous video that we are working with the data that will be downloaded from this DYGIS website. Now I'm just going to download the administrative areas for Nepal. You can just go to this website, which I will put the link down in the description below, and you can just simply click Nepal and then go to the administrative areas and download the shapefile data from here. So you can see that it has actually different administrative levels. So this administrative level 3 is the one that corresponds to the districts. So I'm just going to directly import this shapefile into our Python interface using Geopandas. I'm going to create a new variable called Nepal districts, and that's going to be gpd Geopandas read file. You can basically just specify the path where you save those files, and over here out of the shapefiles.shp files, just going to import this npl underscore administrative boundaries 3. Just copy this one and paste it over here. Now when I press F5, you see that no issues. This Nepal districts you actually can see that it's over here it shows as a data frame, but let's say if we can actually check the type of Nepal districts, and it shows over here that it's a geodata frame. Why is it a geodata frame? It's because of this reason. You can see that it has numerous number of columns along with this column, which is called the geometry, and that geometry column is the unique reason why this thing can be recognized as a geodata frame, because all the spatial properties are sort of embedded within this geometry column. And if you can even simply visualize this just by typing .plot. You can see that we were actually able to plot an image of the districts. You can even make the figure a little bit larger, maybe 8 by 8. Yeah, now you can see actually it shows you the different districts of Nepal. And now let's have a look at the attributes table again. You can see actually we have different columns, and somehow this name 3 refers to the name of the district. So out of all these columns, I'm only actually going to acquire this name 3 column and the geometry column. The reason for acquiring the geometry column is actually I still want to retain the geometrical properties of this shapefile. So similar to what we did before, we can just specify the 2 columns that we would like to acquire. name 3 and geometry. Yeah, I think this one has to be all capital. Alright, now if I open this Nepal districts over here, you can see that it's only the name 3 and the geometry column. Now we can even plot and see whether we sort of damaged its geometrical properties or not, just by typing plot and running the command. And no issues over here. You can see that it got plotted without any issue. So I think we are fine. And this name 3, I'm just going to actually change the name to be districts. So similar to what we did before. Dot rename. Name 3, that's going to get renamed as districts, or maybe district, and specify this to be in place equals true. Alright, now if I open it again, you can see actually this thing got renamed as district. So now you can see actually we have the district information from two different sources. One is from this shapefile and the other one is from the population data. Both has the same column, a common column with the same name. Now I also want to actually have a look at the coordinate system of this map. So what you can do is you can actually just type this variable over here, and if you type .crs, it actually shows you what is the coordinate system that we are using. We are using the WGS 1984. That's the this EPSG 4326 actually refers to WGS 1984. How do I know that? You can just simply copy this one and Google it. And this should give you the information of what EPSG 4326 refers to. But now the issue is actually this is a geographic coordinate system, and the unit of the geographic coordinate system are in decimal degrees. But now, since I'm going to do a population density map, I actually need to calculate the area of each of these polygons over here. So I need the area to be in meters. So I'm just going to actually do a transformation of this coordinate system from a geographic coordinate system into a projected coordinate system. Now I found out that actually EPSG 32645 is one of the UTM projected coordinate systems which is actually used for Nepal. So this kind of information you can easily find out in internet, what kind of a projected coordinate system is being used by different countries. So I'm just going to sort of reproject this. And now even if I open this Nepal districts, over here you can see actually the geometry column is formed with these numbers such as this 85.5, 27.7. These are actually decimal degree values. So if I do something like this, and here we can simply specify the EPSG code, and it'll recognize that it's 32645. Alright, now if I press F5 and if I open this Nepal districts over here, you see that these values got changed immediately. Before it was 82 something, but now it's actually these things are in the units of meters. So this is exactly what I need. Now if I actually were to calculate the area of each of these polygons, the resulting values would actually be in square meters, and that's what I would require for this exercise. So that's done. Now one more thing to actually just notice over here is that if you check the length of these the number of districts that we get from this from the table that we acquired from that website, you can see actually that we have 77 districts. But if you look at the population data that we acquired from the website, you can see that it has over here, you can see that it has 77 rows, which corresponds to 77 districts. But somehow the information that we acquired from the GIS files over here has only 75 districts. So I'm actually not going to spend much time on finding out which one is the correct one. So for the time being, since I'm actually going to produce a population density map, I'm just going to stick to this. I'm just going to assume that whatever the value they show over here, which is 75, is sort of correct. And because the object of this exercise is actually not to find out which information is correct, just to show you how we can utilize Geopandas and these Python techniques to sort of acquire data from the internet and basically generate the population density map without any hassle. So just before we proceed into the next step of combining this data from these two different sources in order to generate one population density map, I'm also just going to actually do a cross-checking again, just to verify that the data from both of these sources are same, basically. Because in most of the cases when we acquire data from multiple sources, there is a high chance that either some of the data could be corrupted or it might not correctly overlap in the way that we would expect them to be. So what I'm going to do is actually I'm just going to run a for loop again over each of these districts. And for example, if I select this district, I'm just going to again open this population data which comes from the website and check whether this name exists in this set or not. For example, if I take this the first name of Bhaktapur, and then I'm just going to actually sort of scan in all of these entries just to find whether Bhaktapur exists in here or not. You see that it actually exists over here. And once you find that it exists over here already, you actually move to the second one, then do a scanning again. This is just to verify that for all the 75 entries that we have over here, we also have sort of a similar entry over here, which has exactly the same name in terms of the district, so that later on we won't run into any issues. So the way to do that would be actually again through a for loop. So we can create a for loop over here. For loop which is based on the data which was acquired from the GIS source. So for in and now we can directly say that we can look inside this district column. So I specify over here district, and now since we narrow the thing down into a column, we can no longer say that we are iterating over both of the rows. So now this just one of these columns actually will be termed as a series, a Geopanda series. So if one were to actually iterate through a series, we call that iterating through items. So that particular piece of code is called iter items, because you're basically iterating through the items of the panda series, of the Geopanda series. Now what I'm going to do is actually I'm going to look through this collection of data, which is actually the name of the districts. So rather than trying to actually scan one by one, I can sort of put this whole thing into a Python list. So what I can do is actually I can just say that population data to list. Sorry, over here it should be population data, and then I have to specify the district, I mean the name of the column, and that one to list, which sort of transforms the whole thing into a Python list. And now if we are checking for each iterating row whether that string is actually in that list or not, if it is in the list, I would say that don't do anything, just make it a pass. But if not, just give me some sort of an indication. Let's say print the district row is not in the population data list, something like that, just so that it gives us some indication. Now let's run this command and see what happens. Okay, there's a small spelling mistake over here. It should be iter items, not items. Alright, now you can see that when we run this command, we actually get some kind of an indication saying that this particular name is not in the population data list. Alright, now I think we will have to just open it one by one and see how it looks. It sounds something like Sindhu Palchok. So I'm just trying to find out whether that thing is over here or not, whether that particular name is here or not. Actually it's over here, but you can see that there's a slight difference in the spellings, the way actually it has been spelled in the data which comes from the website. I'm sure the situation is same for this one as well. Sheet 1. Yeah, there's supposed to be one letter A over here, Chitawan, according to the GIS source, but then according to this source it's Chit 1. So, and you can see actually the situation is similar for others as well. So for example, this Kapil Vastu has been spelled as Kapil Vastu over here, with V. So we have 1, 2, 3, 4, 5, 6 entries which sort of needs to be corrected. Unfortunately, since this involves sort of a correction of spellings, we might have to do this manually. So this script we just wrote just to check whether it has something or not. So I'm just going to sort of replace. So what I'm going to do is actually I'm going to sort of take this population data which comes from the website, and I'm going to replace the name that you see over here, which is this, by the name which is supposed to be given, which is supposed to be the one that's given in the GIS source. And I'm going to do it for the others as well. So I'll actually just speed this up because it's sort of repetitive work. You can see that the name which is over here is Tehratum, but then over here it's TER. So somehow I'm just going to accept that this is the correct name. So I'm just going to replace the original source by the name, this one. Which is supposed to be this. Alright, now you can run this command. And basically if you shift this to be here, and if you run the thing again, you see that we actually do not get this particular code does not get any response over here, because there aren't any sort of mismatching words anymore because we replaced it over here already. So that means we are actually almost at the end of the tutorial. Now what I'm going to do is actually I'm just going to create a new area over here, a new column over here, and then specify the area of each of these polygons in this new column. So how do we do that? Districts. So we go to the and I'm going to specify the area by simply typing Nepal districts.area, and this will actually give us the area in square meters. So I'm just going to divide it by 10 to the power 6, 1, 2, 3, 4, 5, 6 to convert that into square kilometers. Now let's run this one and see what happens. Alright, now you can see that we have a new column called area. So each of these districts are actually having this much of an area in square kilometers. Alright, now what I'm going to do is I'm going to actually take this shapefile and I'm going to take the population data from this pandas data frame that we have, and I'm going to do an attributes match. That means if I sort this out, if I sort this out from A to Z, so you can see that we have this the first district called Acham, and over here we also have the same district, and I'm just going to actually transfer this population information into a new column over here based on the name of the district. So let's see how do we do that. Actually you can do that quite easily using the attributes join operations provided by the pandas library. Do an attributes join. So how do you do that? this is equal to dot merge, and what we are going to actually merge is the information that we are going to merge is actually coming from this population data frame, and we are going to do the merging based on the name of the district, because this is the common column for this one and for this one as well. So we are going to actually do the merging based on the name of the district. Alright, so let's see how that looks. Now you can see that we actually got the correct population over here. For example, if I cross-check from here, you see that this value got copied to a new column called population over here. And now it's quite straightforward. We create a new column over here called population density, and basically the population density for each district is going to be the population divided by the area. So that gives you how many people are there per 1 square kilometer in that particular district. So that information is going to be presented for each of these districts. So how do you do that? We can which is equal to we first create a new column called, well, I'm going to name this as POP, population, DEN, density, and somehow I would actually also like to have the units, to show the units as well. And the units are actually going to be basically the number of people per 1 square kilometer. Alright, so that it makes more sense, and for someone who is reading, it clears things up immediately. And that's going to be the column population divided by the column population divided by the column area. Alright, now we can run this command, and if I open this, you can see that there is a new column called population density, which has the units of people per square kilometer. Well, you can see actually still it has some decimal points, but if you're talking about people, it should be actually integers. But yeah, I think that makes sense, but I'm not going to change this one now. But basically the idea is that in this, for example, if you talk about the capital city, which is Kathmandu, you get a density of 4,211 people per, or if I round it up to 4,212 people per square kilometer, as opposed to cities like this Dolpa. This city has only basically about five people per square kilometer. So this is how actually the variation of the density sort of manifest in this column. So that's actually going to be some very important information in representing the population density of an area. So now it would be actually nice to plot this in a map. So we'll do some very simple plotting. Plot and I'm going to actually do the plotting based on the column, which is pop den people per SQKM. Alright, let's hit F5 and see what happens. I think I might have made a mistake in typing the column name, so let's see. I think it would be safe to just copy it from here and paste it over here. Now let's run this one and see what happens. Alright, now you can see actually something got plotted, but I would like to change the color scheme. So you can actually change the color scheme by inputting this argument called CMap, and I'm going to select the color scheme as spectral. I also would like to have a legend. Equals true. Right, now let's plot this one and see what happens. Alright, now you can see actually it shows us a very clear indication of how the population density varies in Nepal. Now you can see if you look at these areas in the middle. Now if you actually focus to these areas in the middle, you can see actually it has the highest population density, which is about 4,000 people per square kilometer, and that actually happens to be the capital city of Nepal, which is Kathmandu. And by the time you reach to the outskirts, you can see actually sort of the population density drops. So this is how you can interpret this map. You can even sort of save this map into a JPEG. Save fig. Density Nepal .jpg. Now if I press F5, you can see that we have the JPEG file over here. And it looks something like this. So it's sort of an indication of how the distribution of the population density varies regionally for the case of Nepal. So it's obvious that you can actually do further amendments to this figure just to make it look a bit more prettier. You can do some changes to the legend, you can add the title, include the units over here, but these kind of graphical operations I will keep it to another tutorial, because the main objective of this tutorial was to actually sort of to show you how to clean up some data when it contains stuff that is not really required by us, and to sort of isolate things that we need to generate some data which makes sense. In this case it was actually the population density of Nepal. So I think it would be a good exercise for you to follow along this tutorial, because all the data we just downloaded, and I showed you how to even download the data starting from the beginning of the tutorial, which is actually the first part of the tutorial, so you might have to start it from there again. The links down in the description below, so I would actually suggest you to just follow the tutorial along and then try to replicate the result by yourself. That'll be a good practice for you as well. So that's about it for this tutorial. It's a bit of a long tutorial, but I hope you learned something, and if you have questions and if you appreciate the work, you just put a comment down below, so that I know that you actually enjoy these kind of tutorials, and then I'll keep making them, just to give you new knowledge about how to employ the Geopandas library in Python. Alright, so thanks a lot. So I'll see you in the next tutorial.